2008 National Electrical Code introduced a significant change regarding arc fault circuit interrupter protection. It requires arc fault circuit interrupter protection for all 15 and 20 amp branch circuits supplying outlets and dwelling units, with a few exceptions. Let's consider the pros and cons of arc fault circuit interrupters. Firstly, arc fault circuit interrupters can detect and interrupt electrical arcs that can cause fires. They provide an additional layer of protection against electrical fires, which are a leading cause of residential fires. Secondly, arc fault circuit interrupters have been shown to reduce the risk of electrical fires by up to 50%. Now the cons. Firstly, arc fault circuit interrupters can be more expensive than traditional circuit breakers. Secondly, they can sometimes trip unnecessarily, causing inconvenience. Thirdly, some electricians argue that arc fault circuit interrupters are not necessary because other existing protections, such as ground fault circuit interrupters and smoke detectors, already mitigate the risk of electrical fires. The National Electrical Code Committee determined that the benefits of arc fault circuit interrupter protection outweigh the potential drawbacks. They believe that the arc fault circuit interrupters provide a significant safety enhancement that justifies their inclusion in the code. The reaction to the arc fault circuit interrupter requirement has been mixed. Some electricians have embraced the change, recognizing the potential safety benefits. Others have expressed concerns about the cost and potential nuisance tripping issues. The National Electrical Code's requirement for arc fault circuit interrupters in dwelling units is a significant change that reflects the ongoing efforts to improve electrical safety. While there may be some debate about the necessity of arc fault circuit interrupters, the data supports their effectiveness in reducing the risk of electrical fires. Ultimately, the decision of whether or not to support the requirement is a matter of weighing the potential safety benefits against the potential drawbacks. Let's delve a little deeper into the technical aspects of arc fault circuit interrupters and their application according to the National Electrical Code. An arc fault circuit interrupter is a circuit breaker that breaks the circuit when it detects dangerous electrical arcs. Arcing can occur for various reasons, such as damaged wiring, loose connections, or frayed insulation. These arcs generate heat and can ignite surrounding materials, leading to a fire. There are two primary types of arc fault circuit interrupters: branch/feeder arc fault circuit interrupters and combination arc fault circuit interrupters. Branch/feeder arc fault circuit interrupters protect against high current arcs, typically those that occur between a hot wire and a neutral or ground wire. Combination arc fault circuit interrupters offer broader protection, detecting both high current arcs and low current arcs, including series arcs within a cord. The 2008 National Electrical Code and subsequent editions mandate the use of combination arc fault circuit interrupters in most residential circuits. The specific requirements are outlined in Article 210.12 of the National Electrical Code. It's essential to consult the latest edition of the National Electrical Code for the most up-to-date regulations. Typically, the National Electrical Code requires arc fault circuit interrupter protection on all 120 volts, single-phase, 15 and 20 amp circuits supplying outlets installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, or similar rooms or areas. There are some exceptions to these requirements, such as for specific appliance circuits. However, it's crucial to review the National Electrical Code carefully to ensure compliance. When installing arc fault circuit interrupters, it's important to follow the manufacturer's instructions and the National Electrical Code guidelines. Arc fault circuit interrupters are typically installed in the electrical panel in place of standard circuit breakers. They have a test button that should be used regularly to ensure the device is functioning correctly. If an arc fault circuit interrupter trips, it indicates that it has detected an arc fault. It's crucial to investigate the cause of the trip before resetting the arc fault circuit interrupter. Common causes of arc fault circuit interrupter trips include faulty appliances, damaged cords, and loose wiring connections. Identifying and addressing the underlying issue is essential to prevent future trips and ensure electrical safety. Many electricians have strong opinions about arc fault circuit interrupters, and it's worth understanding some of the common arguments. Proponents of arc fault circuit interrupters emphasize their ability to prevent electrical fires. They argue that arc fault circuit interrupters provide an essential layer of protection, especially in older homes with aging wiring. They point to statistics showing a significant reduction in electrical fires in areas where arc fault circuit interrupters are widely adopted. Critics of arc fault circuit interrupters often cite the cost and the potential for nuisance stripping. They argue that arc fault circuit interrupters are more expensive than traditional circuit breakers, adding to the overall cost of electrical installations. They also point out that arc fault circuit interrupters can sometimes strip for no apparent reason, causing inconvenience to homeowners. Some electricians also argue that other safety devices, such as ground fault circuit interrupters and smoke detectors, already provide adequate protection against electrical hazards. They believe that arc fault circuit interrupters are redundant and unnecessary. The National Electrical Code is updated every 3 years, and the requirements for arc fault circuit interrupters have evolved over time. It's essential to stay informed about the latest changes to the National Electrical Code to ensure compliance and best practices. The National Electrical Code is developed by the National Fire Protection Association, and it's widely adopted throughout the United States. It provides a comprehensive set of standards for electrical installations, covering everything from wiring methods to grounding and bonding. In addition to the National Electrical Code, local jurisdictions may have their own electrical codes and regulations. It's crucial to check with the local authorities to ensure compliance with all applicable codes. Proper electrical safety practices are essential to prevent electrical fires and other hazards. Always use qualified electricians for electrical work and follow the National Electrical Code guidelines. Regularly inspect electrical cords and appliances for damage, and replace any damaged items immediately. Avoid overloading electrical circuits and use surge protectors to protect sensitive electronic equipment. Install smoke detectors on every level of your home and test them regularly. Have your electrical system inspected periodically by a qualified electrician to ensure it's in good condition. By following these simple precautions, you can significantly reduce the risk of electrical fires and other electrical hazards. Let's talk more about how arc fault circuit interrupters actually work. An arc fault circuit interrupter is designed to detect the unique characteristics of the electrical arcs. An electrical arc is a discharge of electricity between two or more conductors. Arcs produce a distinctive electrical signature that arc fault circuit interrupters are designed to recognize. Arc fault circuit interrupters use sophisticated electronic circuitry to analyze the waveform of the electrical current. They look for patterns that indicate the presence of an arc fault. When an arc fault circuit interrupter detects an arc fault, it quickly interrupts the flow of electricity, preventing the arc from escalating into a fire. The speed of the interruption is crucial. Arc fault circuit interrupters are designed to trip within milliseconds of detecting an arc fault. This rapid response time can prevent the arc from generating enough heat to ignite surrounding materials. Arc fault circuit interrupters are designed to differentiate between normal electrical activity and arc faults. This is important to prevent nuisance tripping. Normal electrical activity, such as switching on a light or starting an appliance, can create temporary fluctuations in the electrical current. Arc fault circuit interrupters are designed to ignore these normal fluctuations and only trip when they detect a sustained arc fault. However, in some cases, arc fault circuit interrupters can be overly sensitive and trip unnecessarily. This is often due to electromagnetic interference or other factors. There are several types of arc fault circuit interrupters available, each designed for specific applications. Branch/feeder arc fault circuit interrupters are designed to protect against arc faults in branch circuits and feeders. These arc fault circuit interrupters are typically installed in the electrical panel and protect the entire circuit. Combination arc fault circuit interrupters offer broader protection, detecting both series and parallel arc faults. Series arc faults occur within a single wire, while parallel arc faults occur between two or more wires. Outlet branch circuit arc fault circuit interrupters are designed to protect against arc faults at the outlet. These arc fault circuit interrupters are installed in the outlet box and protect the wiring and devices connected to the outlet. Each type of arc fault circuit interrupter has its own advantages and disadvantages. The choice of which type to use depends on the specific application and the level of protection required. When selecting an arc fault circuit interrupter, it's important to consider the following factors: the type of circuit being protected, the level of protection required, the potential for nuisance tripping, the cost of the arc fault circuit interrupter. It's also important to choose an arc fault circuit interrupter that is listed by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association. Listed arc fault circuit interrupters have been tested and certified to meet safety standards. In addition to arc fault circuit interrupters, there are other devices that can help protect against electrical fires. Ground fault circuit interrupters are designed to protect against electrical shock. They detect ground faults, which occur when electricity flows through an unintended path to ground. Surge protectors are designed to protect against voltage spikes. Voltage spikes can damage sensitive electronic equipment and can also cause electrical fires. Smoke detectors are designed to detect smoke and alert occupants to a fire. Smoke detectors should be installed on every level of the home and tested regularly. By using a combination of these devices, you can significantly reduce the risk of electrical fires and other electrical hazards. Let's discuss some common misconceptions about arc fault circuit interrupters. One common misconception is that arc fault circuit interrupters are a replacement for ground fault circuit interrupters. This is not the case. Arc fault circuit interrupters protect against arc faults, while ground fault circuit interrupters protect against electrical shock. Both types of devices are important for electrical safety. Another common misconception is that arc fault circuit interrupters are only required in new homes. While the National Electrical Code requires arc fault circuit interrupters in new construction, it's also a good idea to install them in older homes. Arc fault circuit interrupters can provide an extra layer of protection against electrical fires, especially in homes with aging wiring. Some people believe that arc fault circuit interrupters are unnecessary because they have never experienced an electrical fire. However, electrical fires can happen to anyone. Arc fault circuit interrupters can help prevent electrical fires before they start. It's important to remember that electrical safety is an ongoing process. Regularly inspect your electrical system, use qualified electricians for electrical work, and follow the National Electrical Code guidelines. By taking these precautions, you can significantly reduce the risk of electrical hazards. Consider some additional tips for troubleshooting arc fault circuit interrupter trips. If an arc fault circuit interrupter trips, the first step is to identify the cause of the trip. Check for any obvious signs of damage, such as frayed cords or loose connections. Unplug any appliances or devices that were in use when the arc fault circuit interrupter tripped. Reset the arc fault circuit interrupter. If the arc fault circuit interrupter trips again immediately, there is likely a serious electrical problem. Contact a qualified electrician to investigate. If the arc fault circuit interrupter does not trip immediately, try plugging in the appliances and devices one at a time to see if you can identify the culprit. If you suspect that an appliance is causing the arc fault circuit interrupter to trip, have it inspected by a qualified repair technician. Sometimes arc fault circuit interrupter trips can be caused by electromagnetic interference. Try moving the arc fault circuit interrupter to a different location in the electrical panel. Make sure that the arc fault circuit interrupter is properly grounded. A poor ground connection can cause nuisance tripping. If you have tried all of these troubleshooting steps and the arc fault circuit interrupter continues to trip, it may be defective. Contact the manufacturer or a qualified electrician for assistance. Remember, electrical safety is not something to take lightly. If you are not comfortable working with electricity, always hire a qualified electrician. Staying informed about the latest electrical codes and best practices is an ongoing process. Take advantage of resources such as the National Electrical Code, online forums, and continuing education courses. By staying informed and taking the necessary precautions, you can help prevent electrical fires and other electrical hazards. Now let's explore some advanced topics related to arc fault circuit interrupters. Arc fault circuit interrupters and surge protection devices both play a role in electrical safety, but they protect against different hazards. Arc fault circuit interrupters protect against arc faults, while surge protection devices protect against voltage spikes. It's a good idea to use both types of devices to provide comprehensive protection for your electrical system. Arc fault circuit interrupters can sometimes be affected by electromagnetic interference from other devices. This interference can cause nuisance tripping. To minimize the effects of electromagnetic interference, keep arc fault circuit interrupters away from other electronic devices and use shielded wiring. Arc fault circuit interrupters are designed to self-test periodically to ensure that they are functioning correctly. The self-test feature typically involves tripping the arc fault circuit interrupter and then automatically resetting it. If an arc fault circuit interrupter fails the self-test, it should be replaced immediately. Arc fault circuit interrupters are constantly evolving as technology improves. Manufacturers are developing new arc fault circuit interrupters that are more sensitive, more reliable, and less prone to nuisance tripping. Stay informed about the latest advancements in arc fault circuit interrupter technology to ensure that you're using the best possible protection for your electrical system. Arc fault circuit interrupters are an important part of a comprehensive electrical safety plan. By understanding how arc fault circuit interrupters work and following the National Electrical Code guidelines, you can significantly reduce the risk of electrical fires and other electrical hazards.